Hi, Steve Cale here. In this video, I'm just going to quickly walk through some router configurations, R1 and R2, in terms of setting up a VPN between two endpoints. So I've got R1 here and R2 here, and I want to establish a VPN tunnel between R1 and R2 so that the 10 network, 10.0.1.0 network, and the 192.168.1.0 network can communicate securely across the internet. So we've got the internet in between. So here we've got our two configs, R1 and R2. So you can see here, the first thing we need to do is we need to make sure that we've got the appropriate licensing. So you can see here, we're using a 1941, and we need to use the K9, security K9 license in both. The other thing we've got is we've got our ISACAM policy. And for our ISACAM policy, we've set it as policy number 1. So we're going to use AES-256 with a pre-shared key, Diffie-Hellman group 5, and a lifetime of 3600. And you can see that, these are the same on both R1 and R2. Here's our key. So Cisco 12345. And in this case, on R1, our endpoint is 172.30.2.2. And on R2, our endpoint is 172.30.2.1. So you can see here we've got 172 on R1, we've got 172.30.2.2 as our endpoint, and for R2 we've got 172.30.2.1 as our endpoint. Here's our transform set. So you can see here for the transform set we're giving a name R1, R2, and we're using ESP AES, and we're using ESP SHA HMAC authentication header. You can see it's the same on both. And here's our crypto map. So you can see here for R1, we're using IPSEC and ISACAM in our crypto map, and we're setting the peer on R1 as 32.2. Yep. And here on R2, we're setting the peer as 32.1. Yep. PFS, perfect forward sequencing. We're using Diffie-Hellman group 5 on both. That's the maximum supported by this router. Set security association lifetime to 900 seconds. Set our transform set as R1, R2. Yep. You can see there's our transform set, R1, R2. And we're matching address 101. So if we have a look at our address, then here, we've got access list 101 permit IP. Let's look at our other one. So we've got access list 101 permit IP on R1 from the 10.0.1.0 network, communicating with the 192.168.1.0 network will generate any host on this network trying to communicate with any host on this network will generate interesting traffic to establish the VPN. Similarly, at R2 over here, any traffic being established from the 192.168.1 network going to the 10.0.1.0 network will generate interesting traffic on R2, which will cause the establishment of the VPN tunnel. So either tunnel endpoint can establish the VPN based on the ACL triggering interesting traffic. Okay, a couple of other things that we've got here. So we've got serial 000 is configured. You can see here 172.32. And we've also got a ACL applied, and we've got the crypto map applied as well. You can see with this one, it's got 32.2. It's got an ACL applied, inbound ACL applied, and it's got the crypto map applied as well. Let's have a look at the inbound ACL. So here's the inbound ACL for R1. Here's the inbound ACL for R2. So we're going to permit IP traffic. In R1, we're going to permit IP traffic from the 192.168.1.0 network, which is destined for the 10.0.1.0 network. Yeah, so we're going to allow IP traffic. We also allowed ICMP from 32.2 going to 32.1. So we want to be able to ping from this tunnel endpoint, from the tunnel endpoint here to the tunnel endpoint here, to know that we've got internet connectivity. We're also going to allow UDP from 32.2 to 32.1, which is ISACAM. So that's happening over UDP. So that's for phase 1. And we're going to allow ESP and AH from 32.2 going to 32.1. Now for R2, it's actually the reverse, because obviously the traffic's coming from 32.1 and it's going to 32.2. So you can see here it's coming from and also our IP traffic from the 10 network to the 192.168.1.0 network as our destination. And then we've got ICMP, UDP, ESP, and AH, which is coming from 32.1 going to 32.2 as far as R2 is concerned. Now this is on the inbound. So this is applied inbound into serial 000. So you can see here serial 000 inbound. So it's the traffic coming in. In this case, it's the traffic coming in. So that's our serial interface. The only other thing we need to have is we need to have an IP route. So we've got an IP routes. So we've got here a route from the 1.0 network. So IP route 2, sorry, from R1, we've got an IP route to the 192.168.1.0 network, and we're going to use serial 000 as the exit interface for any traffic that's bound for this network. Similarly on R2, we've got a route to the 10 network, 10.0.1.0 network, and we use the serial 000 exit interface to get to that network. Okay, well that pretty much sums up all of the configurations for these two. So if we wanted to test this, we can go and grab our packet tracer. And here's my packet tracer. So if I was to go and look at this router and R1, and do enable. And first of all, I want to have a look and see whether I've got a crypto map. So I'll do show crypto map. Oh, sorry, show crypto IPSEC SA. Yep. And you can see here I've got a crypto map set up. Interface is serial 000. Had some traffic happen already, and yep. And I can also use the show crypto ISACamp SA. And see, I've got nothing there at the moment. Okay, well let's try pinging and see what happens. So let's go to here, and let's do a ping from 10.0.13 to 192.168.13. So I'm going to ping. Going to take a while to establish. First one times out, and then we're getting some replies. So we are able to ping between 10.0.13 and 192.168.1.3. So let's now have a look and repeat this command. Now you can see here now that what we've done after the ping generated the interesting traffic, and now we've got our tunnel established. And you can see here our destination is 172.32.2. Our source was 172.32.1. Yeah, and our connection now is active. So you can see here that creating that ping generated the interesting traffic, which matched the ACL, which caused the tunnel to be established. And now you can see that the status is active. So if I now do an IPSEC SA, you can see here that you probably haven't noticed it, but you can see here that this is active. ESP SAS is active, and this one is active on the inbound and the outbound, and the number of packets has increased. Whereas before there was nothing active before I generated that interesting traffic when I did that show crypto IPSEC SA. Great. Okay, I hope that's been helpful. Thanks very much for watching.